Following, I want to go over our notes today. There are some who've been bored in here lately. I'm sorry for that. I would say today is the day you will be on board, and in some ways, yes. And other days, it's really something you already knew before. So let me tell you our plan. Our plan is to use our little blue thing that obviously took a miracle to make. We're going to make an exponent rules book. Most of us already know most of the rules of exponents, but everyone needs a refresher. Plus, going to make sure there are some specific things you do know. I got to know. I'm going to put homework problems in the exponents book, but they're going to be so pretty easy and so fast that by the time I write them down and you write them down in your book, you're going to go ahead and know the answer and write down the answer. So really, you're not going to have homework. So to fix that, because you should have homework in a pre-AP math class, there is a packet that we haven't done on, or an LTF lesson on maximizing profit. It involves linear inequalities. It's what we just took a quiz on yesterday. Graphing two at the same time. So I'm going to give you the packet. It's going to be due on Monday. It's going to be a 6% category grade, and it's going to be an easy grade. All I'm going to do is look through Zach's. Did he do it and answer every question and try his best? He did. He can get all his points. Did Zach give up and still not send out an SOS, not come see me 0 period? He just left it blank. He's not getting all his points. So it should be an easy 60% category grade for us all. But I thought the booklets were an easy 60% category grade for us all, and look where we are. So we shall see. We shall see. Okay, so just because you get through that quickly, you could always be working on your maximizing profit at the end of class today, because we should get through our notes pretty quickly. You're a very smart class. That's why I'm frustrated with you. You're so smart, yet so immature at the same time. It is okay. What is my first step on number 1? We have to get y by itself. How can we do that? Okay, so if I divide everyone by 2, I have 2x minus 1 greater than or equal to y. And if I were you, I would rewrite it so it reads something like y, some sort of inequality symbol, and then 2x minus 1. Because you and I like to graph things. You especially. You love y equals mx plus b. So you probably want it y on the left. If I put it on the left, what symbol do I put for my inequality? Yes, dear. I put less than or equal to. Okay, if you've forgotten how to do that, remember that we can read our inequality backwards. So really it reads y less than or equal to 2x minus 1. The only reason this matters is because if Kennedy saw this one, she was going to shade above, because greater than, she thinks shade above. Now Kennedy realizes, oh no, I was supposed to shade below on this graph. So if you put your point at -1, and it is a very tiny coordinate plane today, for that I'm sorry. You plot your points, and then when you connect the dots, you use a solid line or a dashed line. Okay, so I use a solid line, and then do I shade above or below? Below, because it's less than. If you did not read it backwards, you shaded above, which means you shaded, good gravy, the wrong solution set. Our shading is telling us the answers are down here. So if you shade the wrong region, you're saying the answers are in the wrong spot. Okay, on our second bell ringer, it says 9x minus 3y is less than 0. What is the first thing I need to do?
Divide. Add 3y.
We could add 3y. I was going to subtract 9x, but you can add 3y and you're still going to end up in the same scenario. So I have -3y is less than -9x, and you can write plus 0 if you want. I don't. Okay, and then I divide by -3, and I get y and 3x, and what do I not need to forget? Flip the sign because I divided by a negative. Thank you, dears. Since it's a plus 0 right now, I put my intercept at 0.
Hi, we're peer helpers, and we're wondering if anyone had donations for Mr. Lacey.
Mr. Lacey, that would be really sweet of us. I do. Hold on. Here's a, one of our janitors who's on the way. Okay, so I've got my intercept at 3. Count it up 1 over 1. When I do connect my dots, what kind of line do I use? You're welcome. What kind of line do I use? Dotted or solid? Got it. Okay, so I probably should put some more points before I start going crazy. And hopefully yours is prettier than mine, because mine is pretty jinkety looking, but it is okay. Do I show it above or below? Above, because it's greater than. Okay, good grief. You're making me nervous then. Are there any questions about this? I swear you have that down, which is why we're moving on to new things today. You have your little thingy. Hopefully you glued your middle. I haven't glued mine. My bad. We're going to name it, and you probably also want out a piece of blank paper because, let's face it, especially us girls, we write big, so there might not be enough room inside this tiny blue booklet to put all the math we're about to try to do. Now, you already know most of this, like I said. We're just wanting to have a good refresher, and then you can always use this slip book in the future if you're needing help. You can use it like in a future class. I'm going to call it Miss Compton's Nifty Miss Compton's Exponent book. You can call it Maggie's Exponent book if you want to, or Owen's. I don't care. I don't care. And you can decorate the front later however you want. I'm going to put a math joke, but you don't have to put a math joke if you don't want a math joke. I put we love powers. You don't have to have a math joke if you don't want a math joke. I know some of us are much more creative than Miss Compton. If you want to make it super pretty and colorful, you can. And I'm about to color it up, so if you want to color it up with me, that's great. Okay, when you flip it open, I'm actually going to write on this long little flap. Now, a lot of these questions are going to be things you already know, but still got to make sure we got all our vocab terms down for this section. Okay, I'm going to write, my first question is, what is an exponent? What is an exponent? I did. Now, I'm sure everyone in the room, because we've done many math problems together now, everyone in the room can identify an exponent. But as for an actual definition, I'm not sure who in here would tell me anything using the word base, which is what I want to hear. So I'm going to say it tells you how many, you would like for me to zoom in, times. It tells you how many times you multiply the base by itself. So we ask the question, what is an exponent? And our answer is, it tells you how many times you multiply the base by itself. That's going to lead us into an obvious question to follow that up.
What's a base?
What is a base? And I would love to hear someone's actual answer for this one. What is a base?
Any real number? I don't know.
What is a base?
Oh, it's the big number.
It is a big number, and I'm literally going to put the big number.
The number is
It is, so I'm going to put the big number. The way Maggie said it is the way I wrote it too. The big number, but there's something else I want to add. Or This is algebra. What happens a lot? What do we use a lot of in here? What makes this different than what you did in like 5th, 6th, 7th, 8th grade?
It's harder.
It is. Why is it harder? What do we use all the time?
Calculator.
Pencil.
Oh my god.
Variables. Thank you, Zach. The big number or variable beside the exponent. So the big number or variable beside the exponent is the base. And I'm going to write an example to myself. Jackie, what's your favorite small number? 2. 2 to the third is going to be my example. The 2 in this case is the base. And then the 3 would be the what? The exponent. And please someone be oh so fancy and tell me what vocab word we would use instead of 3. Yes, you're in my room for period. I'll leave.
Okay.
Cubed.
I didn't. I was opposed.
Yes, she floats to different classrooms. Yes, I know.
I'm not even caught up to where I am right now.
I'm so glad it's you because she emailed me to see if I would do it, and I didn't want to give up my planning period. I need my planning period. Although I'm bummed she's not here because no offense, Mr. Parker, she was going to take him to the lab, so I could have had my room, but it's okay.
Well.
It happens. Okay, so if it's 3, we say cubed. So instead of saying 2 to the third, Kennedy's fancy and she says 2 cubed. There's another one that has a special word. What is it? Squared. 2, we say squared. We don't say anything fancy with 4, 5, 6, 7, etc. I wish we did, but we don't. Okay, there's one more question which kind of explains why we're filling in this booklet, which would be what are the properties? Because as you already know, there are specific rules we use when we're dealing with exponents. So we ask, what is an exponent, what is a base, and then what are the properties? What are the properties? We're not going to answer that. Everything else we fill in is going to be the answer to this question. Okay, we're going to talk about 2 specific properties today. We're going to save many of the others for tomorrow. Today we're going to do multiplying and dividing. If you're ready. Anyone still not got that? Okay. Let's turn it to the normal way. Now, I don't know how you weaved yours in and out. If yours is blue on top and not white on top, it is going to be okay. Just go with it. Every other. It's just so it can stand out. So the first topic we're going to talk about is multiplying. But specifically, we're multiplying like bases. Multiplying like bases. Okay, Riley, favorite variable? Variable? Yeah. X. Typical. And we'll do x to the, you liked 3, okay. And then I'll do x to the 4. What do I do? And I put x to the 3 and x to the 4 just on the flap so I could look at it. What do I do when I multiply like bases? You have to add the exponents. If Riley had told me x to the 3 and I had written y to the 4, they can't go together. You can only do the like ones. Okay, let's flip to the other side of the booklet. So I was writing on the white, and I'm going to write on the blue. Multiplying like bases. I see x to the 3, x to the 4. I'm going to write that down. And then when you flip, on this side is where we're going to do our examples. So as you know, we need to add the exponents, but instead I'm going to use the other vocab word for exponents, which was my joke on the front, add the powers. So Riley said x to the 3 times x to the 4. What is the answer to that problem? X to the 7, because we just add them together. Everyone's bored with that one, right? Everyone's got that. So now I'm going to step it up a notch and put more than one variable in our problem. So what if we had y to the 7th times y to the 6th times x to the 9th? What would that be? Not that. Y to the 7th times y to the 6th times x to the 9th.
X to the 9th power 4, y to the
15th?
13th.
Okay, and then how did you say it, Jameson? Okay, I'm going to write what he said, but Ashanti is also completely correct. And in fact, Ashanti's doing what I would rather you do. He puts it back into ABC order. X came first, so x to the 9th, y to the 13th would be his answer. Is this incorrect? No. Does everyone tend to put things in ABC order in their minds? Oh, yeah. Oh, yeah. Are there any questions about this one? Does anyone need another example of this? This should be pretty good and an easy review, so you'll be happy to hear you have 2 on your own, which I bet you, again, I'm sure you'll have them done by the time I get them written down. Your homework is to simplify x to the 3rd y squared times x to the 5th y to the 6th. You need to simplify that one. And you need to simplify a cubed b to the 4th c times a to the 5th b squared c to the 6th. Let me read that one again. A to the 3rd b to the 4th c times a to the 5th b squared c to the 6th. And so tomorrow I'm going to make sure you filled in your problems and we'll go over the answers, although most of us are going to have it done by the time I flip back to the main flap. Okay, if you want to write it on your own paper so you can show your work or whatever, because there's not a lot of room here, I definitely understand that, especially the girls like me who write large. I understand. Okay, is there anyone who doesn't have the problem down? Let's flip back. Okay. We're going to flip back to the front flap in just a second. We wrote multiplying like basis, and now we're going to put dividing like basis. What do I mean by the word like again? They have to be the same variable. We can't put different variables together. Whew, that came out slow. Okay, so let's flip back to the front. Multiplying like basis. Now we're going to do dividing like basis. Maddie, give me a variable. No. I'm sorry. Be fancy. M for Maddie. That's good. M to the Maddie, since I yelled at you, will you tell me a number?
To the 3rd.
3rd. I'm going to do that one in the bottom. I'm going to do 8 in the top. I like 8. When we divide and we have like bases, which we do in this case, what do we do with the exponents? Yeah, so when we were multiplying, we added. So it makes sense when we divide, we subtract. So what should my answer be in this case? M to the 5th, because you did 8 minus 3 and you got 5. 8 minus 3 and you got 5. We're going to work a couple of examples on this flap. So just, girls, be prepared to write small once I flip over. Okay, when you flip over, put subtract the powers. Because when we divide, we subtract the powers. We're going to do another easy one, a medium, and then a hard. So let's do the easy one's going to be t to the 7th divided by t squared. What should I get for that one? Does everyone agree with him? T to the what? Fifth. Okay, 7 minus 2 is t to the fifth. That's what I'm going to call our easy. For our medium, let's have a few more variables going. E to the ninth, F to the sixth, G to the fifth, divided by E to the third, F to the fourth. E to the ninth, F to the sixth, G to the fifth, divided by E to the third, F to the fourth.
Can I say it?
Yes, go for it.
Okay, E6, F2, G5.
Okay, I agree with you. 9 minus 3 is 6. 6 minus 4 is 2 for the F's. And then G to the fifth, there was no one else to subtract him from. That's why he stays G to the fifth. Does anyone have any questions about that? Everyone's cool with that? I would consider that in the medium. Yes, dear.
So if it was numbers on top of the bar line, I mean, same variable on top, will we?
Add them together first and then actually do it. Yes. Okay, so Ashanti's already getting to what I want to talk about next. I'm going to do one example in this little slot that I have, and then I'm probably going to need to do a couple more examples on my paper that I have behind it, because this is where life gets a little hazy. Okay, 7 minus 2 is 5. That's great. What if I redid that green problem and instead did t to the second in the top? That's supposed to be a 2. It's ugly, but it's a 2. And t to the seventh in the bottom. Then what would happen? What would you get for your negative? Okay. Are there any questions about that?
No, that's okay.
No, we're going to fix it. Don't jump the gun now. Okay, so Mr. Parker can probably tell us why, but this is what I told third period. Listen, this is Mr. Parker. We are not allowed, we talked about their specific rules in math class. We talked about why we're not allowed to divide by 0. I have like a logical reason as to why that cannot happen. I do not have a logical reason as to why, but trust me, nobody likes a negative exponent. We have to fix it. We're going to punish him for being negative. You cannot have a negative exponent in your final answer. Now, if the problem gives you a negative exponent, you can wait and fix it at the end, or you can fix it at the beginning. And I'll show you in just a second. So we're going to have to punish him right now. Is he in the numerator or the denominator right now? He's understood to be in the numerator. He's understood to be over 1. So to punish him, we're going to have to send him where he doesn't want to go. So we're going to send him to the denominator. So it becomes 1 over t to the fifth. It is now positive. We punish him and send him where he doesn't want to go. We punish him and send him where he doesn't want to go. So our answer is not t to the negative fifth. Our answer is 1 over t to the fifth. Okay, so I'm going to work a few more like this because I'm with you. Like, that's why can they not just accept the negative exponent? They can't. They just don't like it, so we cannot leave it that way. They will not. They will spit. Like the vending machine spits back out your dollar. It will spit back out your problem because it will say no. They do not want negative exponents. Okay, so we just did t to the fifth. Oh, good gravy. T to the second over t to the seventh, and we got t to the negative 5. And we said that was 1 over t to the fifth. Oh, you can't see what I'm doing. You were good with that one. So let's do another one. Let's do x to the third over x to the ninth. What will we get then? Tell me the final answer. 1 over x to the sixth, and then I said it wrong. 1 over x to the sixth. So Hiram's right with the in between step, but we cannot leave it that way. We have to go 1 more over. Okay, so if you're negative, we punish you, and we send you where you don't want to go. So right now he was in the top, and we punish him and send him to the bottom. it does go the other way. So you might be given a problem to begin with that's, for instance, 1 over x to the negative 9. He's already in the bottom. Sending him to the bottom is not punishing him. We have to punish him and send him where he doesn't want to go. He wants to be in the bottom. So we have to send him to the top. Are there any questions about this?
What do you do in the black? Like, I don't get that.
Over x to the negative 9.
Like, that's a whole new problem?
Yes. That was my third one, yes. He was in the denominator and he was negative already. You send them where they don't want to go. Since he was negative in the bottom, send him to the top and he'll be positive and he'll be mad because he wanted to be in the bottom. Okay, so if we had the problem, and this is the real challenge of the day, well, I say that and then I'm going to give you 2 on your homework and you'll be like, really, Miss Compton? Okay, x to the 6 over x to the negative 1. What should I do? I can work the same problem out 2 different ways. I would love to hear how you would work it. Okay, so Zach wants to do x to the 6 minus a negative 1. And so you really add and get x to the 7th.
Wouldn't that be 7?
Yes. Yes. So minus a negative is actually a plus 1, so you get 6 plus 1, which is 7. You can do it Zach's way, if that makes sense to you. So minus a negative and it becomes a positive. If that makes sense to you, you can do that. Or, so Zach is choosing to fix the negative at the end if there was an issue. Or Zach could fix the negative at the beginning. He could say, x to the 6, you're okay. X to the negative 1, no. Not going to work. I'm going to punish you and send you to the top. So you're really x to the 1. And when I multiply, I add the powers, and I get x to the 7th. Whichever way you like better is the way you can go. If you want to do, which is what I know Ashanti wanted to do, if you want to fix it to begin with, you can. Or if you want to deal with the negative and fix it at the end, you can. But Maggie will be in trouble if her very final answer has a negative exponent. We don't like them. Are there any questions about our examples? Okay, well then here are your 2, which are a little more challenging than your multiplying ones, I think. Dividing would be so easy if it weren't for this negative issue. Okay, for your homework, you need to simplify. For A, we're going to do A to the 9th, B to the 3rd, C, divided by A squared, B, C to the 7th. It is highly possible in one of these problems that you have to punish someone and send them to the top or bottom. Of course, that's what I'm going to make you practice for homework. Okay, in our second problem, I'm going to write it in a different color so it doesn't blend. It's going to be x to the 2nd, y to the 4th, z to the 7th. And then you're going to think I'm a meanie. X to the negative 6, y to the negative 4, z to the 3. I need you to simplify both of these.
Can you read the last part again? Not the...
X squared, y to the 4th, z to the 7th, divided by x to the negative 6, y to the negative 4, z cubed. You're welcome. Are there any questions about any of these? If you want to, because I know Wendy was writing stuff on her own paper, if you want to actually show your work out on your own paper, you can. Obviously, we don't have enough room for that in our little booklet. So if you want to, that's great. I will check them tomorrow. If you need help with them now, I'll gladly help you. We still have some free time.